Welcome
Hey
everybody!
We are all three of us here today, which is great. We want to say welcome to everybody. I see Fabrizio's in the house. Kaya Lamy is a new member. Hi, welcome. Rick is here. Nice, Rick. I think you're the first person to come in all the time. 4:21. It's like 40 minutes ago. You sat down to wait. We appreciate it. Yeah, William Barry. Tim's here. TR. KS Pack 6, that's a new name. I don't recognize that one. So welcome. What else we got here? Hey, everybody, just say hi and where you're from. That'd be cool. We love it. Eric Dunn. Lawson's here.
Oh, he actually made it this time.
Bankrupt. Actually made the live stream. Welcome, Lawson. I don't know why I'm talking like that.
I don't know either.
That's weird. No, this is awesome. So we are going to go through a little bit of what we've been doing over the last couple days since Sunday's video went out, this morning's video. And then we've got Brent here. And Brent is going to go through our SLD. And trust me, it took me 2 weeks to figure out what an SLD was.
SLDs.
Yes.
In process.
And we'll talk about what an SLD is because I didn't know. Northwest Coast is here. Okay, Blaine, are you ready to say what this was all about?
All right, so this is how the engine room actually looks right now. And the way that it got this way is yesterday I tackled the most disgusting, horrible, wouldn't wish it on my worst enemy jobs of steam cleaning the entire engine room. And it is terrible. It blows crap all over you. It was in my eyes, and you can't even wear goggles because they just fog up immediately. You can't see anything. Like you're just safety squinting everywhere trying to make this happen. But yeah, I think I was on it for 4 hours, something like that. Got all the greasy, nasty, slippery stuff off, and yeah, it's pretty awesome. It's nice and clean down there. Don't have to worry about slipping everywhere when you're crawling through there. And now we just got to do a little bit of wiping on the walls, and we're good to go.
It is so clean, except for right down the middle.
Yeah, right in the keel. That's the only place that you don't go to, because when you start blowing the pressure washer in there, that's when things really get messy.
Yes, and I'll talk about real quick the glue on that aluminum and what our choice is, what we're going to do.
So the glue, as you can see on the walls, did not get phased by the steam cleaner, and that is a hot water pressure washer is basically what it is, and it didn't even phase it. So what we're going to do is we're going to go in there, we're going to scrub that all down with soap and water, get it nice and clean, and we're just going to glue over the top of it. And right now we're thinking a higher density polyethylene foam glued into the back with bevels cut on either side so the limber holes can drain down past it. We'll probably get a 1 inch thick bit of that, and then we're going to get a 2 inch thick rock wool to lay down to fill up the rest of that void, and then plywood's going to go over the top of that. So it should work out for a well draining and good insulated hull.
Yeah, and yes, Fabrizio, I did remove all the insulation, and the steam cleaner did remove all the loose particles of glue. So that glue on there it's stuck.
It is stuck.
So Patty's here. Hey, Patty. Tony Ortiz is here. Ortiz. Hey. Oh, Burdette's here. Earl Cowley's here. B. Tolan's here from Greece. Hi. Saskatoon. I hear it's cold over there. Lawson, everyone loves a single line diagram. It's coming. Are you guys ready? So is there any questions first about what the engine room is? Because we are on full destruction now. Or sorry, we have completed destruction mode.
Eric says perforated sheet over the insulation would provide sound deadening, and it certainly would, but in my experience dealing with it it's harder to clean. I really would like a flat surface for that, and it does my eyes in when I'm trying to work around it or do stuff with it. It just, man, it throws your eyes for a loop when you're close to it.
Yeah, those little dots.
I would say to that, and you're absolutely correct, that there's a very good chance we'll end up with a perforated ceiling pattern. So there'll be a larger, denser, better insulation layer between the floor and the salon. So, and that's usually where we would look at doing a perf, 1 or 2 foot square pieces that you can mount up that are sound deadening panels as well, because then the reflection of sound you get inside the engine room doesn't have a chance to come up through the floor.
And my walls are still easy to clean.
And your
Perfect.
walls are still easy to clean.
Want to say hi to Teresa. Hi to Julian Hunt from Saskatoon. Teresa's my cousin. Love her dearly. In Thunder Bay. And Sandro, Burdette, Tim. Okay. We are going to leave the comments to the end like we usually do. If you have comments throughout, please put them in because we're going to hit all those questions and answers throughout. And let's start with Brent adding to the stage. Ready? Go.
Hey guys, we can just pass over this one. So what we did initially, and I'll define our process here, just so everybody understands how we went from this concept a couple of years ago to where we're sitting today. So I would argue that almost every vessel is a unique platform when it comes to what's the ideal way to electrify, or I like to say optimize the efficiency of the vessel. And we take a look at a lot of different factors. One of them here is the basic performance curve for Tangaroa. Can we zoom that out for them at all? Or
They see it a bigger screen than us.
okay.
I can't, sorry.
So what you can see about Tangaroa is we have not addressed the planing power that would be required to get this thing up over 14 knots. That curve would go almost vertical after where it is. In discussion with Blaine and Janice, we basically said, okay, how do you use the boat? What speeds do you see as being what you actually operate within? And how do you operate the vessel within those speeds? Are you cruising some of the time? Are you at faster cruising some of the time? Are you at high speed all of the time? What's your criteria? How do you like to handle the boat? And this power curve came from limiting, if you want, from the 0 to just under 13 knots that they typically would operate in. And I would say they've always been very comfortable with the idea of cruising at around 8 knots, 7 knots, 9 knots, something in that wheelhouse. So we use our displacement performance calculations for this kind of hull, and that gives us a required number of kilowatts to move the vessel at these various speeds. So you can then sort of peg where you think you want to go. And if you guys will notice on the chart, it shows that about 45 kilowatts is what they need to do their cruising speed. So we start with that, and that is really the basis for the design of the boat. Now we could probably go on to the...
Before we do that though, I'm just going to quickly touch on something. A lot of people consider that is not a high enough amount of power to push this boat through the water. And when we first started talking, you said you used this spreadsheet on how many boats?
Over 600.
And how accurate have you found it over those 600 boats?
It's generally overstated.
Yeah. So there you go.
So this is based on a gentleman named Dave Gear who created a hull performance modeling tool, naval architect. He's been around for a long time. He's out of New York. And we found it to be quite accurate. And we compare this. So when we look at the design of a propulsion system, we use the mass and hull friction and et cetera to come up with this kind of a curve. And then we go back to our propeller manufacturers and we ask them to generate a performance curve. Then we'll get to even work with the generator or motor companies to generate their own performance curve so that you can both match the propeller, which is super important on a boat like this. And e-motors tend to use different propellers than you would find typically on a diesel engine normally. I just got back from commissioning a boat in Australia. She was a small crew transfer vessel, only about 27 feet. But we decided to try running the boat with the original prop, which was a 28 by 21 prop. And we actually have to go down to a 20 by 16 to take advantage of the lower horsepower and the different RPM range that we can get with an e-motor on that boat to get the perfect speed. We were actually pretty overpropped as it was for it, but nobody wanted to buy the new propeller until we had tried and tested and saw how inline the old propeller was, and it was too far out, so we are going to go to another propeller on that project. But we try and compare the performance expectations of everybody. We generally go down about 10% in performance or up in 10% in demand energy just to be a bit on the safe side. And I usually overstate the actual displacement of the vessel by quite a bit because you're always going to carry extra crew, extra people, extra stuff, and that's how you're going to run the boat most of the time. We always run with an extra 6 months of food on board, sort of thing. So that's how we created this as a baseline to start with. It's what we call an under-promise, over-deliver performance curve.
I like it.
Next one.
So this basically is a cartoon SLD, and all of these pretty much until we get to the end are of what was on the boat when we started. So
Can you explain what an SLD is?
Oh, sure.
Because I didn't know.
You didn't know?
No, I had no clue. You kept saying SLD, and I was like, I don't know what he's saying.
I really got to come up with a good anachronism for it then.
Yeah, sorry, I had no clue for about 2-3 weeks.
Anyways, I short long disorder. I don't know, but the an SLD is single line diagram. So when we start with the design of a vessel, you have a single line diagram that is very much like this, just to rationalize the concept of what we're doing. So this is where we were, SLD, saying it is a pretty conventional vessel approach to setting up the structure with shore power, normal 12-volt battery systems, and engines that are driving really everything, including your charging. And one of the things about doing a serial or parallel hybrid is that you have to change the way people think. So it's kind of like driving an electric car versus driving a fuel-driven car. Until you've driven a Tesla, for example, you don't really understand why somebody would want an electric car. But once you've driven an electric car and you get to experience the acceleration, you get to experience the longevity of the of the car in range. You get to experience the vessel in terms of all the other things you can do with that electricity. My car was my office, so I would comfortably work in it for 6 hours at night when we were camping, where I could be quiet in the car, have my computer plugged in, have my climate control on, and I could never have done that with my truck or my fuel-driven cars. You can do that with a battery-driven vehicle. And so in a boats like that too, in that one of the goals and one of the expectations is that what we're doing is creating a platform that you don't have to make decisions about what you turn on or off. You can do whatever you want. You can incorporate electric cooking. You can incorporate really any normal AC appliance that you have use of in your house, and that you have enough availability of energy and the capacity to turn anything on or off that you like as you go through and use the boat. And at the same time, with all that extra power and energy you also have the ability to charge the boat quickly, but not run the generator all the time. So you can have a big enough battery bank, if you have the space, to buy yourself days of off generator time. And the two things that people value the most are silence when you're out boating. You want to have quiet. And then you don't want to be the Johnny generator in the harbor that drives everybody crazy. And then the other thing is simply you want to know that you can have a household fridge or a household freezer, and you can have air conditioning running, and none of it's a compromise. You don't have to worry that it's going to turn off, or you must run your generator within a period of time and it won't work. So we're buying you freedom of experience, if you wish, and then creating an environment that gives you the ability to relax. So silence is golden, and it's absolutely true when you're out on a boat and you can hear the wind or the birds more than you can hear your own boat. That's the experience we're all looking to achieve. So once we settle on the performance curve, I'm going to go to the next one.
Yep. This is where we are today, right?
No, that's where you were.
This is where we were.
You are no more. You have nothing in the
Do you have a blank page for where we are today?
Blank page for where they are today.
There we go.
So then when we take this concept and take it out to the market, it might surprise you, but generator manufacturers don't think anything about operating their generators constant speed, constant power. If you go and ask somebody for a generator profile, they'll tell you you should use it so much at 25%, 50%, 70%, and then you have some time at MCR, or full power. The idea of constant power, constant speed is very unusual, and frankly, it scares them a little bit when they start looking at these kind of projects. When you tell them that the generator isn't there primarily to drive the propeller, but that the generator is there primarily to charge the batteries, that's also a bit of a head spin. And then when you go down the road that the batteries are going to drive the propulsion system primarily, and supply power to the hotel loads, etc., on board, it kind of gets outside of everybody's head. Everybody understands the concept of a serial hybrid or a serial parallel hybrid, but they don't really understand how they're going to do it. So this is a overview SLD, and it's very draft, but it's not meant to tell the company how they're going to supply us with an option. It's meant to give them the opportunity to tell us from their perspective the right way to execute this. So we've had people come back to us and say 2 generators, not 4, 3 generators, not 4, different sizes of battery banks, different sizes of propulsion motors, variety of different power electronics packages to convert power from A to B to C, different voltages. And the key to the success of our approach in this, and what's worked for us really well over the last couple of decades, has been that we are boat builders. We're battery guys, but we're boat builders. So in my world, if I go to a company to provide a generator for me, I don't tell them how I'm going to install it. I go to them and say, okay, if I'm going to use this is my duty profile, and this is how we're going to use this product, but what's the best way for us to configure your product to make this work? And how should we install it best to make sure that it has the highest opportunity for a long, reliable, service-free life? We're trying to optimize propeller uptime, if you want. That's our goal. And I'm old enough, and I don't know if I'm smart enough or stupid enough, but to know that there's a lot of smarter people than me in the market space who know a lot more about their specific products. And if you ask someone for that level of input into what you're doing, it always pays attention to listen and see what they come back with, both with the things that can go right and the things that can go wrong. One of the things that people pointed out right away when they saw this SLD, single line diagram, is that we needed to put some protection on the generators if they're going to operate in parallel to not go asynchronous and cancel each other out. So when you have an AC generator, they have to modulate the phase so that everything is aligned all the time, so that the generators can both work together and ramp up, or they can shut off, but you're not going to create any problems. And in the commercial world, where I think the most number of generators I've ever seen on a ship was 8, and they are all in parallel with a multi-stage controller, they would typically say that any commercial vessel in the world will go asynchronous once a year. And what happens when the generators go asynchronous is we get what's called black ship. So basically there's no power on board. And these guys are such good engineers that usually within a couple of minutes they can have a ship back up and running again. But it's a scary moment for them. And so somebody came back to me with that concern, and it's completely valid with AC generators, is that if you do have generators in parallel, you have to have phase control, and you have to be able to manage that really efficiently. And that's not free, and it can be complicated depending on the generator, because a lot of these smaller generators we're talking about, in this case 50 or 100 kilowatt generators, there's not a lot of money invested by the host companies to give them that megawatt scale generator balancing and ability to operate. So
especially in the marine sector, we found.
Yeah. And Blaine's participated in a lot of phone calls with these guys, because I want him to understand the scope of the decision that these guys are going to make at the end of the day about what product we're going to put on board. And you have to hear what people say, because almost always I love suppliers because they'll tell you the answers to the test. And they'll caution you with the things that they are concerned with, the problems that they deal with every day, once they realize that you really are there to be their blank slate for the ideal installation. And then they usually help us with other elements of the power electronics and the batteries and everything else. Some of it they don't know anything about and they want to learn from us. Other parts they do have some experience and knowledge, and they want to bring I like to call it scars and road rash, to the table so that we can benefit from their experience as well. And the goal of going out to all these different companies, and I think we've spoken to 7 different generator companies and about 4 integration companies at this point. I think we're on integration company number 5 right now, is that you want to see what kind of relationship is going to develop out of the experience, because the sale and the installation is quite literally 1% of the experience for Blaine and Janice. Right? 99% of their experience is based on being out somewhere in the middle of nowhere, going somewhere.
It sure works.
And wanting a boat that's going to get there, right? It's pretty simple. But people in the engineering side of things get so focused at the beginning stages of the sale and what the elements are of the sale it's hard to predict what that service relationship is going to be like, but we qualify all that up front. So as we progress in our conversations with people, one of the key things about dealing with OSEA in this world is that we take all of the product on board and revert with a 10-year, 100% guarantee on the product that it's going to work. So that's something that you got to have confidence in what you're doing in order to be able to take on that level of risk for a system like this. And in this world where we don't have an onboard living generator engineer, no offense, I know you're a mechanical engineer.
I can make it happen.
You're basically putting the onus on the integration of the system because you don't have a full-time engineer or crew of engineers running the boat all the time. It has to work at a higher level of reliability than even our commercial industrial platforms have to. So super, super, super careful to do all this stuff. So you'll see now and in the future, we'll be releasing more of these draft SLDs until we get to the final version of it.
Okay, can we go back to this one?
Yeah.
Okay, so this was the initial SLD that you came up with, right?
Yeah.
Can you walk us through it real quick to show people?
I can barely see it.
I know, I'm sorry.
All right. So
You made it.
I know it. It's all in here. So again, the key to it, I don't know if you guys can see where my finger's pointing, but
I can't.
I'm looking at the battery and the propulsion part of the screen.
Can I get a...
Can you do a mouse or anything on it? Oh, I don't know. Anyways, so we always start with that part on this because the propulsion element of the battery driving an e-motor with a motor controller in control of both sides that's where the rubber kind of hits the road with a lot of the engineering partners that we bring to the table when they realize, oh, they're absolutely not talking about some sort of car version of a hybrid. This is a true electric vessel with a hybrid charging system at the end of the day.
Sorry, I got nothing. I can't do it.
Okay. And then from there, you now treat your generators really as like a power plant. So think of that as your substation that just happens to be on board the boat, and then your chargers. And the batteries, so the generator effectively is going to run the chargers, which are going to charge the batteries. This SLD's actually got a couple of mistakes in it, but we'll just deal with the purpose of what it was for. And then you have to think about, where am I getting my hotel power? How am I getting everything on board powered up? And in this case, we're taking that power from the main battery bank. So the generator's only job in the world is to charge the batteries. We will end up with a parallel emergency drive on board so that you can use a hydraulic pump off of a PTO on one of the generators to drive a chain on the shafts to have forward and reverse if the batteries completely die. But that's for another conversation. In this case, think of the purity of the system being the generators charge the batteries. The batteries drive the boat. The batteries supply the power via inverters and then DC to DC converters for your 12, 24, 120, and 240 volt demand. And then just in the distance in the back, you have your shore power plug that can plug into charging the batteries or providing the power to the 120 bus as well. So,
but we don't need that shore power cord.
Well, you don't at all. Like,
do we have the solar built in here?
No, the solar's not in the drawing yet. And that's the other thing. Whether it's a sailboat or a powerboat, we treat renewables like solar and wind as unvalidated energy. We don't know how much they're going to get. We don't know if they're going to get any. So we don't incorporate it into the key propulsion driveline of the boat at all, or the key charging scenario. We have to say that whatever else happens, you have the generators to charge the batteries. If you have solar and that extends your battery life by an extra day, great. If you have wind and that gives you an extra day, great. But there'll be days when you don't have solar and there'll be days when you don't have wind, so you're going to rely on your generators to do it. The other thing with this boat is the concept of 4 generators. So if you go back to this power curve quickly. So again, if you think that they're going to achieve their 90% of the time use cruising speed with about 45 kilowatts of energy, a 50 kilowatt continuous power generator is enough on its own to deliver that cruising experience with a little bit left over for charge. So, and that's the goal. The goal is that you want to leave harbor with your batteries at whatever state, but arrive at your next stage, your next anchorage, with your batteries full, So you don't immediately have to go on the generator. All you need to do is drop the hook and get set, and then you can stay for as long as you like. To do that, you need a little bit of charging capability coming off the generators, and that's determined by how much hotel load demand you have. But really what you're looking for is that propulsion power. And if you have, in this case, a 300 to 400 kilowatt hour battery bank, you can eat energy if you need to out of the battery until you need to turn on generator number 2 and charge the batteries again. So that does a couple of things for you. It means that if you're running 24 hours a day, you're only putting 6 hours of that 24 hours on each generator at cruising speed. So if you think about that in terms of an annual impact, and let's just pretend that they run 24/7 for 8,400 hours a year, instead of dealing with an 8,400 hour maintenance number, they're dealing with basically a 2,100 maintenance hour issue. So the cost of maintenance and service on the generators is spread out over a much longer range of time. So it effectively is less per year than you would do if you had one engine or two engines running continuously. And my example is taking up way more time than they would probably use anyways, but it's reflective. And then if you do need to bump the generator, so you need to go from 45 to 70 kilowatts of propulsion power or 90 kilowatts of propulsion power, you'll use the battery in between the two generators to deliver the power until the battery state of charge comes down to 60% or some predetermined number. And then that will signal generator 2 to turn on. And when generator 2 can spool up without load, so it comes up to load speed if you want, then the battery will withdraw from the charge side of the fence and drive side of the fence and become something that the excess capacity of both of those generators is now charging. And you do that all the way through the 4 generators if you need to go to full power. And you always have the battery on the power on top of the 4th generator, where you can add more power if the wheel will take it in terms of propulsion effort. One thing we did here, which is probably not what we're going to do in the boat, is we show here on the boat 2 chargers, one from each side of the generators. What's quite likely going to happen if we stay with an AC generator package, to avoid the problem of the going asynchronous, we're going to keep the generators isolated to the chargers. So each generator would have a 50 kilowatt charger, and that way you can turn them on and off as you go and you want to increase the speed of your charge or just the maintenance of your charge. So that's kind of an interesting concept, and it basically takes away the issue of asynchronous operations. It does add an element of cost, because you're now having one charger per generator instead of having one large charger or 2 smaller chargers or whatever again. The benefit on Tangaroa is we got the space. So we have the flexibility to make these decisions based on however Blaine and Janice ultimately want to run the boat. So let's go forward now to our first. So this is provided by a company called Rawson's in China. And interestingly enough for everybody, we've been dealing, again, there's about 5 integration companies that are capable of supplying right from the e-motor back to the batteries. So the entire powertrain could come from a single company. May or may not happen because we have to validate the quality of each one of those elements. But there are some real advantages to having an integrated supply chain in that you've got the ability to battle test this system at factory before you bring it onto the boat. And you can validate how it works and make sure you program it the way you want it. And you have one source of service to deal with. That can also be a disadvantage because if they're a crappy service company, you're screwed.
Yeah.
So that's why you want to also spend a lot of time getting to know these guys. I think, Blaine, probably if you can explain your experience of how we had some challenges communicating with people. Rawson's was a good example.
Yeah. Rawson's was a good example. Roy Powell was another one. Very, very nice people, and they want to help, but obviously language barrier is pretty heavy, and also sometimes the initial people that you're talking to are not the people that you should be talking to, and that probably has something to do with they're just better at translating than other people. But yeah, it's challenging. We spent a lot of extra time just waiting for translations to go through. And then even that, some of the times the translations weren't accurate and people were confused. So yeah, it's been interesting. To
But
say
is
the
it not
least.
worth it because their stuff is good? Like everybody thinks, oh, Chinese crappy stuff, right?
Oh yeah. Well, when you guys see when we do the factory tours to look at all of these places, um, you'll see yourselves how they qualify out as professionally available or ready or not. My personal experience, and I've been working in China now for close to 40 years, one way, shape, form, or another, is it takes a huge amount of investment of time to get a partner who shares your DNA, someone who understands what you're doing, why you're doing it, and fully gets your expectation of service and support. I've been working with these guys for several years. I've been on a couple of different commercial projects. They're a good company that needs to be trained from a service point of view. From an engineering point of view and a quality of product point of view, they're quite good. That I would hold them as comparable to a North American or a European supplier. Um, but the language barrier is real, and the cultural barrier is real, and it's one thing when you're communicating with somebody in a meeting and everybody's calm and relaxed and has a cup of coffee. It's a very different communication when you're boat sinking and you have to get something sorted out. So that's where you have to measure the quality of the relationship and the communication capability, because you don't want to, in a panic, not get your point across. But my rule of thumb for meetings in China is, and we've so far with 3 integrators there, is that you have to double the time for the meeting just to allow for the translation and the constant correcting of expectations and cultural differences. And you have to be, as I said to Blaine in one of the meetings, slow down. You can't speak quickly. They don't understand anything that you're saying. Slow down, they'll hear everything, and then they will think about it and give you a clear response. Um, but we get used to speaking to people who can speak English clearly and understand what our objectives are. Uh, it's just quite different when you're dealing with someone from China. We've dealt with now also a company out of the Middle East. Again, some people I've worked with for quite a few years, and we've built about 35 or 40 vessels with them. We're executing a fully electric tugboat right now with them, and really like these guys. They're fun to work with. They speak English, which is great, but I would still tell you there's a lot of cultural barriers there as well. And you just have to, you can't make any assumptions. The key thing here is use the product quality base that you need as the guide to clarify any miscommunications that you have, and never stop asking questions until you get the answers that you need. This SLD is version 3. There'll be version 5 in about 6 or 7 days.
Now, Mikado just wants to say, why aren't these technical drawing standard, these SLDs?
Well, because there's very different ways to do. You can call it a series system, but there's, like, we could have a single generator, a single charger. We can have one battery bank. We can have one propeller or 2 propellers. That would be, I would say, as a concept series hybrid that is pretty consistent.
No, I think what he's getting at is this just looks like chicken scratch on the screen that you made up. That it's not technical. It's not done by an engineer.
I can speak on that as well. This is a design SLD,
exactly,
not an engineering SLD. 2 different things. This is just giving an idea of what the system's going to look like. The engineering SLD will be an entirely different animal.
Yeah.
And again, this is how you create the relationship with the companies, right? We'll go past this to a professionally engineered. I'll show you another one right now. We can go to the next one. Yep.
Here we go. Whoa!
So this is what I'd call more of a typical single line diagram for a system overview. And this is when we talk about engineering and we talk about parts and pieces that are going into it. This is where the questions really get developed and where we answer those questions or come up with an alternative solution that they'll address in the next version of the SLD. So yeah, you do have different layers depending on who you're talking to in the company. And it sometimes can take 4 or 5 meetings to go from the cartoon you just saw to something more like this, which is a little more pragmatic with the correct symbology on it.
So is this our SLD now, what we're planning on, but there's still going to be more iterations? Where are we at with
this is the propulsion guys single line diagram proposal. And there's still one more version of this coming to us.
So these are coming in from companies that want to help us build this?
Yeah.
Okay.
Yeah. And again, the next layer for this, guys, if we were doing a 48 volt system like I have on Karma or what we're doing on Inside Passage, we would have all the drawings executed to what I call U.S. Coast Guard ABYC standard. When we're dealing with Tangaroa, where really it's a commercial solution on a vessel, the drawing standard for this is going to be type approval. So when we do most of our projects, they're done for type approval vessels, which means they're third-party approved engineering, and then they get flag approved because they're all commercial. So they get approved by someone like Transport Canada or the U.S. Coast Guard, and then those become your as-built drawings, not just for this, but for all the systems. There'll be 30 or 40 drawings that come off of this single line diagram for the unique systems all the way down to the switch panel, so that we have a better guideline for doing the actual electrical work. This is still making sure that what you are all on is the same page from a concept point of view.
But we just wanted to show you the SLVs because we are in the designing phase, right? We are getting closer and closer to deciding which companies we're going with.
Yep.
Right?
Yep.
Next one?
Yep. So these pages are really just about the data we're again giving these companies so that they have a clue of the communications that we've had internally about how the vessel is going to perform, what are its characteristics of size and management. You can take this data to literally any naval architect in the world, and they can create their own performance curve based on this information. And they can then, start looking at how they would do this kind of system. The strength of our approach in this is a couple of things. One of the statements we always make is we want the system to be what would be sitting beside the customer, not in opposition to what the customer wants. So much of what we do in the marine industry is that we put something together, and I would go to Blaine and Janice and say, "Here, buy this," right? And that's
and we go, prove it.
Well, usually what happens is in the case of the customers, they say, "Well, I like 7/10 of this, and 3/10 I would do differently," but the guys won't change it for them because it's what they do. On our side of the fence at OSEA, we want to think that we're on board with Blaine, and Janice all the time. And to be on board or to sit beside them means that we have to execute on 10 out of 10 of the things that matter to them on the vessel. And that we are aligning the service and support, which is again 99% of the relationship, versus the 1%, which is engineering and supply. And I was very fortunate when I was younger. I worked for a company out of Sydney, British Columbia called Waterline Yachts. And I apprenticed there as a boat builder, and I worked for 10 or 11 of the smartest master craftsmen in their trades I've ever met or worked with since. And what was quite amazing was at Waterline, there was always a 3-year backlog of vessels to start. And people who wanted to buy their last boat, the last blue water cruising boat they were going to buy, came to Waterline to sort of amalgamate their 4 or 5 boats worth of experience into one vessel. And Ed Rutherford, who was the owner of the company and still a phenomenal naval architect and marine engineer in his own right, his true skill was that even though Ed had a tremendous amount of knowledge and the accumulated knowledge of all of his customers, is that he knew how to listen to what his customers wanted on their boat. And he knew how to reflect that in the vessel. And now we're not building a boat here, but the systems that we're refitting the vessel with, what I'm doing is helping Blaine and Janice to see what the differences are, whether it's cultural and language, whether it's a water cooled or an air cooled, whether it's an AC or a DC, those things all have merit. Like a DC generator would be a perfect thing for this platform. But Blaine and I have spent months and we have struggled to find good DC generator suppliers that work within the context of the size of the vessel. And so we did find one company, a very, very good group out of Louisiana that makes a great DC generator product, but they are not a marine generator. So we went to them and said, "Can you produce a marine version of it?" And he has. But the risk of dealing with a really good company that doesn't know your market is pretty high compared to buying a Northern Lights generator with a large distributor's service network and everything else. So at the end of the day, you have to see the product, and then you have to see the relationship with the supplier. And it has to be the relationship that works with Blaine and Janice. they know they're going to travel this boat all over the world. A lot of people would never leave the Gulf Islands. Some people would be on the East Coast. Some people might go to the Caribbean or the Bahamas. But there's very few people with the adventure and destiny that these guys have where they want to go. So criteria for a supplier in Florida is going to be different than the criteria for a supplier when you're going to be in Japan or Russia or whatever. You have to really think about that in terms of putting the product on the table. My job is to make sure that the choices that we work through are all very credible. They're capable of delivering the product quality that they're looking for. And then we have to see how we develop that service and support relationship with these guys to make sure that there's a really strong connection there, so that they don't have to look up a serial number to know who you are and the boat you have. They know it's Tangaroa, and they know this is the system on board, and they have the living history of it in front of their computers all the time. That's the biggest success we'll have, and the best uptime opportunity they'll have is if that relationship is with people who care just as passionately for their boat as these guys do.
I'm going to interrupt. Guys, we do see that there's a discussion going on in the comments, and we are watching it. We will get into them as soon as this is over, and we will answer them and clarify a lot of things. Okay? Current vessel statistics we went through.
Same
kind of thing.
It's just before and after sort of stuff.
Why are we going serial hybrid versus parallel?
You can go down the road of parallel. For me, an ideal parallel system would be driven by DC generators or DC output generators. And until there is a really, really good DC generator solution that's commercially viable for these guys, my suggestion would say we're better to treat it as a series hybrid with a parallel drive capability. So there's really no good reason for a parallel hybrid system unless you want that specifically to drive off of. In this case, I would say you'd have 2 generators instead of 1, and you would treat them simply as a direct replacement for a diesel engine and create a drive system. That way they would have a clutch of some sort to go from battery powered or diesel powered. But we've found that the batteries are really efficient in terms of transfer of energy from the battery to the drive system, and that the chargers are quite efficient when it goes from charging to the batteries. So you're effectively creating a nice circle, and you've got a lot of reliability and a lot of redundancy built into that system. And when you don't have sales to be your last choice of viability, you have to make sure that the mechanical side has got backups on both sides of the fence, but real capability. And where I like the 4 generator solution here is that you have 4 opportunities before you have an absolute power failure no matter what. And in average, you're going to have 2 battery banks and possibly 4 battery banks. So you've got some of the same kind of redundancy in that package. And then if you can slap a chain or a hydraulic drive onto it to operate if the batteries were to fail, that gives you another layer on top.
Are you doing that?
But trying not to, yeah, here we are, of some sort. But what we're trying not to do is also create a so complex to build and expensive to manage option boat that you kind of defeat the purpose of putting in batteries and an electric drive after all.
Yeah, we want to keep it simple, stupid. And that's why we want to show you that this technology works.
I'm very keep it simple, stupid driven, because I am very stupid. So.
And that's the last slide.
That's it. So Maura, I was really hoping we get into a bunch of conversations here, and I could.
We got some. So we're going to go right into question answers. Please put all your question answers in there, or your questions, and we'll talk it. I do want to say an extreme thank you to Running with Wrenches for the super sticker, super chat. We really appreciate it. Thank you so much. Again, this build is crowdfunded, so all the money that you guys donate, it's your build too, right? This is why we wanted to present the single line drawing. We want your impact. We want your feedback. I see lots of good stuff in the comments. So you guys ready to get to it?
Yeah, let's get rid of the PowerPoint first. So
I can do that. Give me a second.
Work fast.
Remove. Wow! Did you guys see that? Wait, I lost the comments now.
God, you scared me.
What do you mean with my what?
Yes.
It's got to keep you awake, man.
The coffee's for
Okay, so we said hi to everybody. Let's get right down. We talked about the perforated sheet. We talked about the cleaning. Okay, Sandra Rios, sorry. That's huge. Reclaim some of that R to the AC area of the boat. What about moving the workstation and spare parts storage to the excess space and leave the rest of the boat completely free for people? What are you guys thinking about doing with the engine room? Because I thought this was really cool. Because we are thinking of splitting the space.
Well, interestingly enough, and again, what Blaine's done in terms of taking everything out is he really has freed up
And Janice.
Sorry. What these two have really done in terms of the hours and hours of sweat equity that Janice put in, that Blaine supervised, was created the blank canvas relativity. And there's a weird truth to doing this, that it's really difficult to design an existing machinery space and change it. So when you want to add in new generators, batteries, structures, you kind of have to do it in the room. I like doing it with either door skin templates or tape or something, and you just kind of spitball the conversation around, what if we did this, what if we did that. Now, the original plan, as we looked at the machinery space before we took everything out, was we would use the aft wall, which is the broadest part of the machinery space, for where the batteries would go. And so then we started modeling up the batteries and where would they fit and was there enough room and blah, blah, blah. And Blaine discovered really quickly that there was more than enough space for the batteries. We, in fact, had space left over. And then the other things come into play, like you start asking yourself, what are my top 3 problems with batteries? And the number one problem with lithium batteries is heat. So, and in our conversations with all of the generator companies, we went to them with, we want 4 generators that all have sound enclosures so that we can manage heat through the exhaust. That way we can keep the ambient room temperature pretty cool, 35 degrees, something like that. But we can use air to manage the temperature, and then the batteries will live at a nice temperature for operational purposes. Hallelujah. But all the generator guys came back and said, good God, that's going to cost a fortune to have ideal sound shields. And wouldn't it be better if we turned around and just did a better job of insulating the engine room? So leave the generators open. Now, if you leave the generators open, there's no putting the batteries in that room, because your ambient temperature could easily get up to 50 degrees, 60 degrees. When you're in warm weather and warm water, that's a reality of life. And so managing temperature becomes quite expensive, because you're having to either circulate a huge amount of air or you're having to introduce air conditioning. I built a sports fishing boat in Saudi Arabia a long, long time ago, where we actually had 120,000 BTUs of AC in the engine room because it was too hot to fish otherwise, crazy as that sounds.
But let's go back, because we have also had the problem where it's too cold.
Yeah, but
and our lithium batteries weren't charging.
That's not going to be your drama on this thing at all. Okay. But so anyways, while we're having all that discussion, one of the things that came up that Blaine and Janice wanted, or Janice and Blaine wanted, sorry, was that they wanted a tool bench where they're going to put the panel, and a working room for the washer and dryer and things like that. And so you could put the batteries on the back side of that and still have it with the generators, or we could just move the whole wall back a bit and put the batteries on the service side. So it's in with the tool bench and it's in with the washer and dryer and whatnot, and you can see them all the time. And there's still enough room to do that. So then your batteries are now in a much easier to control climate space. The air draw coming down from the stack comes right in on top of them. And then you can push that air back into the machinery space and exhaust it from there to manage the temperature according to the machinery that's in there. And so your batteries are protected from being in a high temperature environment, which is just going to age them. Your machinery is isolated by one more wall from a noise point of view. And then you can really make the decision, do we put in with or without a sound shield? But you're not struggling to service them. You're not struggling to manage them. You can focus your insulation if you don't put a sound shield on them in a much more interesting way. Like the comment that the earlier person made about having the perforated sheet on the walls, it's a lot more relative if it is a completely enclosed diesel machinery space, right? Then sound insulation becomes more of a challenge, and it might be worth considering not having a hard, shiny wall, or you put in a bigger, deeper drop ceiling to manage that transmission to the upstairs and the outside. So with every decision on a boat, it's I learned from a Dutch gentleman a long, long time ago that there are 1,000 ways to skin a cat, and a boat is like that in that you can decide whatever you like, but what you have to do is understand the repercussions or the impact of what's your priority. And in every one of these conversations, we'll talk it through quite a bit. I'm just a sounding board here. I'm a chalkstone. That's all, right? These guys are going to be the ones who are sharing their experience of their space and their desire for their space, and then we're going to look at what does that mean in terms of where nuts and bolts and pumps and machines go, and then basically they can do their own SWOT, strengths and weakness test, if you want, against what decision makes the most amount of sense or is the least amount of compromise or the better optimization, depending if you're cup half empty, cup half full. And that's how we will finalize the design of this. And then what I said to these guys before, which has always been the truth of my experience on boats, is once you stop dithering and you make a decision, then bury it. Don't change it, execute. It's not going to be perfect. It never is. As boat builders, we have a couple of interesting concepts that boats always 6 inches too narrow and 1 foot too short for everything that you want to do no matter what. And it's our job to reduce the feeling of that and make it feel like it's absolutely as good as it possibly can be. And as long as those decisions meet their desires, what matters to them, then they'll feel like they've got good value out of this at the end of the day. If it exceeds it and it does more than they thought, they'll feel like this is a great deal, right? It's not about cost then, it's about value. And that's ultimately how we all take these things forward to make people happy.
So we are getting closer and closer to making a decision. We were thinking about the double walls, but there is something we haven't talked to Brent about, is the problem with the hatches and where they're located on where the wall is going to be, because we have to access both rooms with the hatches that the engines come in and out.
Yep.
Because I anticipate that these are not going to be the first generators we have and that they're going to live in this boat forever and ever and ever. So keeping the hatches open, like one of you guys suggested, was an amazing idea. But we got to figure out how to do that with the wall and the batteries underneath also.
Yeah.
So
Well, you know, the cool thing, and I absolutely was not interested in this YouTube stuff whatsoever.
they got great ideas, these people.
I can say that, but I will tell you comfortably that the feedback that we've received from everybody on this channel has been instrumental and absolutely critical value in terms of helping make these guys the right decision, right? Like when we talked about this months and months and months ago, I didn't understand YouTube at all, but the only thing I said to them is, you don't do this conversion where you're 3 months ahead of the people watching. That's just insulting, and it's boring, and it's no fun, and you don't feel
he's
like
a
you get to
YouTube
participate.
watcher. This is why he's saying this. He's
a
a viewer.
and I hate participating and finding out they made the decision 3 months ago. So if we're going to do this, it had to be that your audience could come along, absolutely have input. There's a number of you who we've had a lot of communication with, both as potential suppliers or ideas or design, and it's been great. It has completely broadened everybody's horizons, and it's forced us to rethink a lot of the initial ideas. But at the end of the day, you can, if you think 100 times and only have to nail it in once, those tend to be the best ideas.
And I do want to say hi to Kendra's here,
Hey,
Menace, Spaceman here, Gary, my brother from another mother, is in from Mexico where he was catching some big ass fish.
Oh, my parents are here too.
Your parents are here,
Yeah.
So it's been crazy. But Menace K04, please tell me you're going to a 48 volt or 72 volt setup to better distribute power with smaller wires amp.
Oh, we're going far beyond that.
Yeah. The battery system is likely going to be a 700 volt to 800 volt battery. It'll be able to operate nominally at between 470 and 560 volts, and from there we will step it down to a 24 volt, 12 volt system on the DC side, and step it down into a 120 and a 240 volt on the AC side. But to reduce the batteries for the kind of power we need for these systems, you do have to go to a much higher voltage. And that allows the cables to, we'll be using probably a 2-aught cable for a lot of the battery to bus bar power, where if you look at my 48 volt system on Karma, I have to use 4-aught cables and I have to use solid copper bus bars because I'm only drawing 800 amps max, but 800 amps at 48 volts is a lot of heat. So to reduce heat, improve efficiency, get better math through to the actual propellers, you want to have a higher voltage system. And even though this isn't much bigger than what we did on Karma from a e-motor side, it's big enough that it rationalizes a high voltage, well, I call it a medium voltage DC system to execute the propulsion side.
I do want to clarify, if you guys are wondering what Karma is, Karma is actually Brent's sailboat, and it is a hybrid electric system. And he actually just sailed it from Victoria all the way down to Mexico. It's down there right now. You can follow him on Facebook, or Pacific Yachting just did an amazing article about Karma. So you can check out Pacific Yachting's website. It's on there. When Pacific Yachting reporter was just doing an interview about us too, which is really kind of cool, but you guys will see that later. I have no clue what he's going to write about. So Steve's in the house in Detroit, nice. Motor City, capital of the world. I don't know why I'm doing this tonight.
I don't know. You're just trying to be trendy.
I know.
From trends a long time ago.
Fabrizio, I'll just ask this now from seeing the initial SLD. It seems the generators go solely to the batteries. I believe you should have the ability to run the e-motors off the generators alone, so in emergency.
Fabrizio, there will be a provision for that. That's going to be determined by where we ultimately locate the generators in the boat. And typically we would, in most commercial vessels, we use a PTO off of the generators that can drive a hydraulic motor, or sometimes we do them with electric, but quite often hydraulic motor that would have cogs on the shafts that we can chain on to that PTO, so that we can use the generators to directly drive if the batteries completely fail.
Well, I think he might be talking about as well. Adam was talking about this, where you could electrically still drive the motors from the generators, even if you had a battery shut down.
Oh, you can to a certain extent. It's a different, like what we're trying to do again is isolate the complexity of the system. And if you have that built in as an emergency power instead of as a primary power, it's a lot simpler as a control mechanism to operate and install this way. But there is absolutely a 100% need for, in any power boat, for some kind of a series parallel element to it to manage the safe drive of the vessel in an emergency.
It's okay. We'll just put Punga in the water. We'll strap her to the bow, and we'll put her in reverse, because I always tow in reverse, and we'll just tow Tangaroa wherever she has to be, and then Blaine will fix whatever broke.
Sure, that would go really well.
That'd be an interesting item on your single line diagram.
I know.
Exactly.
Punga. Okay, Tim is making me jealous with ice cream and popcorn. Thanks, Tim.
Nice.
Yes, Blaine is stuck. Doesn't he look so small when he's in the middle?
It's because we're tiered here.
I know, we are tiered.
Wait till you see the video of him from when he used to work on Galileo.
Yes.
It looks like a 10-year-old driving the boat.
Today we found, or our parents actually helped take the old footage from when we worked on mega yachts, and we actually have that. And I didn't know way back when that, well, YouTube didn't even exist way back then.
It was way before YouTube.
But we actually made videos and edited it all together, and I'll put it out there for our members. You guys will absolutely love it. He is so young. He looks younger than our son right now.
I think I was like 21 or 22, somewhere around there.
Detroit Rider, thank you so much for following. You don't have to donate. The best thing you can do is subscribe, comment, and take part in these conversations like you're doing.
Yep.
That actually really feeds the YouTube algorithm, helps us out. And we kind of really want to really want to get, I know it's a vanity metric. I think it'd be so cool to get our YouTube button and be able to tell our kids that we have a YouTube button.
So tell other people about it.
Your parents are YouTubers.
How many subscribers do you need for
we need 100,000.
100,000.
Yeah, we're almost halfway there. So again, share it. Thank you so much. Steve, Blaine, that's not necessarily someone's name. That's a major appliance.
I don't know. I've never heard of Blaine Appliances.
I don't know. Steve, I don't know what you're talking about. Eric, if the generators are charging the batteries, rectify to HVDC from each generator, no phasing problems.
Right. That's what we have resulted in. If we're going to go AC generators, that's exactly what we're going to do.
Yeah.
Are these new generators going to be turbocharged? You know, I like the sound of the turbos.
They likely will. Most of the ones that we're looking at are, because that's a good way to get bonus efficiency off of any of them.
Yep. One of the interesting things, guys, on the generator discussion is that when the generator guys realize you really are talking about constant speed, constant power, you can tell that is the hardest thing for them to get around their heads. And so when we went to them with the overview, I was really clear. I said, I don't care how big the generator is, it has to be able to produce 50 kilowatts, constant speed, constant power. We're not asking for a 50 kilowatt generator, we're asking for one that can do that. And that has been interesting to see. We've had people approach us with 55 kilowatt generators and 65 and 75 kilowatt generators to do that 50 constantly. In my experience, with my boat, I have a Northern Lights 20 kW genset on. It's called an M844. And same thing, I even have it in email with the Northern Lights guys from when I purchased the generator a couple of years ago. This must be able to deliver 20 kilowatts of continuous power. That's what my metric on my ship is. And they were like, oh yeah, sure, no problem. And when we started having we were struggling to get, I couldn't get past 19.3 kilowatts when I was doing the commissioning. And it quickly kind of settled in that the generator would stall out at about 18 and a half. And that may have nothing to do with the generator. That can be my installation, the exhaust system, a number of things. But their answer was, well, it shouldn't be running that hard all the time. And you should run it at 70% and 50% for some period of the time. And I said, well, that's really great information yesterday. It's not great information today. So it's taught me that we had to go back and clarify that with our suppliers on this case, 50 kilowatt hour or 50 kilowatts continuous. And interestingly enough, the comment they all come back to us with is that pretty much is going to reduce the actual hours life of the generator. They don't know necessarily, depending on the company you're talking to, by how much. But we basically then factored in how much use Tangaroa is going to get in order to determine that we have a 10-year platform, at least on the generator side as well. And again, super smart people we work with. The Northern Lights guys, all joking aside, are a phenomenal company. And I love my product in that category. But the clarity, when you're used to dealing with someone who's dealing with a different parameter of performance all the time, is really important to get that clarity, so that whatever we all agree on the engineering, you're not letting the customer down with what you deliver, right? If I had sold my boat to Janice and Blaine, I would feel obligated to up my generator to a 25 kilowatt generator in order to be able to give them that 20 continuous all the time. That's the only way I can keep my promise to them. And so we've just learned better on how to ask the generator suppliers to keep their promise to us as well.
I do want to clarify, guys. I know last week you said that you love being in the engine room. You can't tonight because it's freaking cold. It is so cold.
And there's nowhere to put the computer down. There's nothing in there.
So hopefully next week we're going to move back to Monday for the lives, and we'll be from the engine room because we'll start watching construction. Okay. Menace K4. Okay, so Battleborn batteries need to be checked for overheating terminals. It's a known problem. Please be careful about the batteries that you use with this build. Look it up, even just FYI.
Yep.
Yeah, we know about the Battleborn. The good news is Brent actually has a battery company. We're not using his batteries, but I would say, is an expert in lithium batteries. We don't want to comment about the Battleborn ones. We don't know exactly what's wrong with them. We know a lot of the YouTubers use them, and we hope it all gets worked out.
Well, the only comment I'll make is there's nothing wrong with the Battleborn batteries. They're being used in a way they're not designed to be used if the terminals are overheating. And so lithium batteries are kind of cool in the sense that they have so much more energy density than lead acid or AGM technology. So you might have 4 times to 8 times more energy in the same box. Okay, so that part about lithium, holy smokes, that's phenomenal. It makes fire management hard, which we'll talk about later. But
another live, not tonight.
Another live. But having that energy density in a small volume of space is an incredible advantage. Now, lithium batteries, though, have to power from the cell to the terminal, right? And if that connection isn't designed to carry a lithium battery's cell's capability, then those terminals will end up heating up. And so they have what we call a C rating. So a typical lead acid battery has a C over 20 or a C over 10. So a really good one, like a Surette, is a C over 10 type battery, or a bit better than that. But an average AGM or crappy lead acid battery is a C over 20, what you have in your car. And that means that it has thinner lead plates, it has less of them, and you can't heavily discharge them for any long period of time, but they'll last for up to 20 hours at 5% discharge, right? So they'll give you 20 hours at 5% discharge state. 10 is 10% over 10 hours. So C rates are really important at measuring and understanding power. And if you look at the Battle-Born batteries, they're just not designed for a power application. In lithium, the way that we would look at the marine industry is that there's kind of three categories of C rate for lithium batteries. One is a C over 3, and that's what most of the product you buy in the marine industry today is. When you go buy something that's an 8D replacement lithium battery at 300 amps or whatever, that is really designed as an energy platform. It's not designed for cold cranking starts. It's not designed to start up heavy duty compressors. It's not designed to turn propellers. It's designed to deliver over 3 hours the energy of the battery. And if you ask to do it in 2 hours, it will heat up. Okay. And if you try and charge it, because charging is where you create the most problems with the lithium battery with internal resistance, if you try and charge it faster than 3 hours, it will really heat up. If you charge it in 3 hours, it'll be perfectly fine. When you do charge something like a Battle-Born product quickly and frequently, you will age the battery a little faster than what they designed to do. If you always charge it over 6 hours and discharge it over 6 hours, that battery will serve you brilliantly in lots of applications. Then we get to the battery we're putting in this boat, which is going to be between a 1 and a 1.5 C, which means that you can charge and discharge it in 1 hour or about 45 minutes. So those are what we call power batteries, and they're designed for managing the short bursts of, you may have a 5C discharge for a few seconds to start a compressor. You may have to run it at 3C continuously for some machinery to get up and running. And it's designed to be able to manage those huge surges, dynamic range if you want, and at the same time take the charge without aging the battery from a cycle life point of view. So we always try and, when we do these installations, we almost always use 1C as the charge. So in this case, we'll actually have almost a 0.5C, because we're going to have somewhere between 340 and 400 kilowatt hour of battery and roughly 200 kilowatts of charger. So if we only put in the original concept of 200 kilowatt hour batteries, we would be charging them in 1 hour, and that would be a 1C system. In this case, we're probably going to end up 0.6, 0.5. So we're never going to be in danger of overcharging the batteries and creating heat from the resistances generated by that. And we're very rarely going to see a dynamic load on this that's ever going to get close to its 1C load of 400, 350 kilowatts. That's a lot of power. But that's what we do. And the important thing in marine, and I've had this conversation, I don't know, I can't even count how many times, is just because it's a battery doesn't mean it's appropriate for your product. So you need to know what your energy requirements are for power, and look for a battery that's designed to meet those expectations, right? And then you will be happy. And whether it's Battle-Born or I don't know, there's a few dozen people doing it. Epic is a good battery for a lot of purposes for hotel loads. It's one of the best engineered products I've seen on the market. But don't choose it because you think it's a good battery, or what's that battery kid's name?
Will Prowse.
Will Prowse. Don't choose it because Will Prowse gives it a good review. Choose it because the power signature of the battery matches the power signature of your boat. Then you have a chance to happy wife, happy life.
I say good.
David asks, is there a gear reduction built into the e-motor so the motor RPM is much higher than the propeller RPM? If so, how do you select the correct ratio?
Yeah, well, that's where we do the math on the propeller in the first place. So e-motors can have a 1-to-1 reduction ratio, typically if it's directly coupled to a motor, and then you have to find a motor with the correct speed of what you're doing. If you have to go to a reduction gear, there's a few ways to do it. you can use a split shaft design, and a split shaft design says that the E-motor shaft comes out with a cog on it, and you design the cog to the drive shaft from the split shaft to give you the shaft speed ratio that you're looking for. The vessel that we just finished in Australia, we made the decision at the very beginning not to worry about designing the propeller. We just were going to throw the boat together as quick as we could and take it out for a run and see how it ran. And as I said earlier, it turned out to be massively overpropped. We were only getting 720 RPM on a vessel that should turn around 1400 or 1500 RPM. And so it meant we couldn't get away with the old propeller at all. We might try cutting it down. Who knows? We'll see. There's a discussion for them for another day. But ideally, that particular motor is designed to run between 1400 and 1700 RPM. And we did that with that split shaft concept because we didn't have any room for a transmission to go into the boat. Beyond the direct drive that has the electric motor at the correct RPM, so you can buy an E-motor that will only turn 1200 or 1400 RPM. A lot of them come at 3000 RPM and do require some kind of reduction. You can also go with effectively a transmission. And where one of the watchers of this channel has a large powerboat we were taking an initial look at in terms of what was its power signature, and to do his proposed speed of 18 knots, he needed 1200 kilowatts of E-motor to get there. And at 1200 kilowatts would give you the 18 knots all day long. But what that meant was you also needed to have a small motor of about 200 kilowatts for that sort of low speed cruising speed range of performance, which is what would still give him about 8 knots of speed. And you had to have then a split E-motor structure with a transmission with two basically power take-ins for the E-motors and a clutch to go between them at the different speeds. Or the 1200 kilowatt motor is too inefficient at low kilowatt performance, and it would overheat and it would die. So that's a much more expensive solution. And so the owner of this vessel can make the decision, how important is 18 knots? And if I want that, then this is the structure to go on. But those transmissions are roughly $300,000. So you're making a conscious, expensive decision for short-term use, and you have to validate that that's okay for you. Or he would compromise it by putting 400 kilowatts of E-motor on and have the ability to do 10 or 11 knots, 12 knots. And is that okay? And I can't answer that question for him. That comes down to the owner and how they're going to use the boat. But the simple truth is you'll get through the design process the ability to choose what your priorities are. Is top speed your priority? Is cruising speed your priority? Is range your priority? And we will design that system to meet those expectations.
So we've got about 45 minutes left. And we're going to try and get through as many questions as we can.
Doing pretty good here.
I know. Okay, guys. So let's go through it. William Mundy. Hi, I don't recognize William's name, so welcome. I agree with others. There's no redundancy. There are systems out there that do the same, but allow you the option of the generator running the drives directly as a backup system, or if your batteries crap out, well, the generators run.
I think we've talked about that a couple of times in this so far.
Burnett wants to know, could one engine run two Jennies?
Could one engine
Run two generators?
In that case, I'd just do a bigger generator head. If you're, I mean, suppose you could. Yeah, I don't think there'd be any benefit to that I can think of.
I don't get the question.
No, just one big engine with two generator heads.
Oh yeah, sure. Yeah, but that would be a unicorn, frankly. And one of the things that's really important in this, if you are local to your supply chain and your support network, then you can be as technically adventurous as you want to be. The more afield you want to travel, the more you have to fall back on super redundancy and serviceability of everything. Because when you're anywhere, you are the only person for 4 to 6 weeks who's going to fix your boat.
Yippers. Willie wants to know, I saw someone here on YouTube that had a small turbine-powered milsurp generator. They got it cheap, and it was dang near brand new. It probably cost the taxpayers $500,000.
Probably.
What's a milsurp?
It's a military surplus.
Ooh.
They're not quiet. it'd be really difficult to keep those quiet.
Yeah.
Well, and again, you come back to serviceability, right? And there's a lot of stuff. I've been involved with a lot of DIY projects, more from a casual observer perspective and advisor. The, there's a lot you can do, and there's a lot that's not addressed by the commercial supply chain today. This commercial supply chain for this kind of project is really limited right now. When I started doing large scale vessels back in 2009, it was just like this, and that there were very few suppliers that could provide equipment that would work with the batteries that we could build to deliver performance solutions of any kind. Fast forward 10 years, so by 2019, sorry, most of the main power electronics companies in the world had completely jumped into the space, developed a huge range of product, and opened up our ability to be flexible with the design of systems and how we could execute ships so much better than we could do in 2009. And today in the recreation space, there just isn't a lot of supply chain yet. There is not a lot of continuity or commitment to the space, because at the end of the day, marine doesn't represent a large sector of revenue for any of these companies. So it's kind of a byproduct of the automotive industry. It's kind of a byproduct of the mining industry, a byproduct of the commercial marine industry. And it'll mature and get better and better. Like our problem with finding a good DC generator in that sort of 0 to 100 kilowatt range, it's an inevitability, especially for those of you who love parallel hybrids. It's absolutely the right way to go. If you ask me, would I do it today? I would say 100% yes.
But in 10 years' time, they'll be so easy to find.
In 10 years' time, they will be a much broader selection and people can choose them. Right now, in North America, there's really only 2 companies that are producing tier-driven DC generators, and one of them doesn't do it in the marine space. He only does it in the mining space, oil and gas. So it's an opportunity as a field if you want, but in our discussions with all of the major generator manufacturers, it's not even on their development plate yet. And so you don't want to be that test pilot for Cummins or an Onan, because then this vessel won't get done this year, it won't get done in 27, it won't get done in 28, it will get done in 29. And you'd have a great generator, but you're living ashore until then.
But we could put in AC generators and then put DC generators in 4 years' time.
Oh yeah, that's absolutely that's practically the safer path to go down, is just commit to AC generators now. Go with the idea that we can swap them out for DC generators when that product becomes commercially viable, right?
And as you guys know, we're totally okay with doing things multiple times.
Yes, remember, never-ending sea trial. What's really cool is John says he's thought about doing this and about how to do this right, and there's so many factors to consider. John, welcome to the channel. I hope you're going to follow along, because there's so many factors to consider, and the fact that we're doing this in real time to try and show you everything we're considering is crazy. Justin says this is going to be cool when it's done.
It'd be very
We
cool.
agree. Tim says, I think electric boats make more sense than electric cars. Interesting comment. Yeah.
It's kind of funny because, in a boat like ours, we are operating in a power range that is ideal for electric. We're kind of always in that idle range, if you want to call it, of driving around, where slow speed motors and not a whole lot of kilowatts is good.
Yep.
Tim's done a great job answering lots of comments. Tim, we really appreciate that as you're answering the comments for us. You guys know some of the answers. There's a lot of smart people watching right now. So please feel free to answer other people's comments also if we can't get to them right away. Oh, guys, I'm so offended. No, we're not. No hard feelings, but this is pure snake oil. Brent, it would be best to bring back the diesels.
Okay.
The Detroits or the Cummins? See, this is really funny, because when we took out the Detroits, we had a lot of people saying we were doing this all wrong, and it was epic fail, and this wasn't going to work.
And from industry professionals, no less.
Yes, the Cummins were absolutely brilliant people. Seriously, 10 gallons to 5 gallons that get up and go. We actually have it on our channel where Blaine did all the tests and everything.
I think the biggest thing is a lot of people base their opinions on what they specifically have experience with, and they assume that everything is the same, and it's not. Everything's different, and like Brent says, every boat is different.
Yeah, and the only comment I'll make on that is that when I started electrifying boats and building the batteries at Corvus Energy back in 2009,
Google Corvus.
I didn't get one suggestion that this was snake oil. I was offered free medication, hospital stays, extended drug holidays, all sorts of things because everybody said I was completely cracky nuts to even think about turning a propeller with a battery. But today, 90% of commercial vessels are designed with battery banks.
Yeah.
For propulsion.
For propulsion. So I get the skepticism, and I'm not offended by it at all.
Yep.
And in fact, sometimes I would say the skeptics I've worked with have been the most practical advice, because you want to show why it's not going to work, and that quite often is a good feature that needs to be built into how it does work.
We like having the skeptics because we actually get ideas from you. So please keep watching, please commenting. We really appreciate it.
Yeah.
But like Rick says, we have had these electric boats since the advent of the submarine. With the advances in battery tech, makes sense to have a hybrid these days.
Yep. It's all about what you're doing with the boat.
And in a boat, the motor can run all the time without turning on and turning off, which causes a lot of external draw or extra draw. Yeah, let's go back to the comments. Steve's right. Well, he does come from, Detroit. I kind of agree, Mako. They have stated that the conversion is not for everybody, but considering how far they are planning on traveling, it makes sense for them. Yes, if you're just taking, I wouldn't spend thousands and thousands of dollars in a hybrid conversion if you're on a weekend warrior.
No,
it's not worth it.
Yeah.
But we are heading to Japan and then down and around Australia, and then we're coming back up through the Northwest Passage. Then it makes sense. Not always, but we're putting big miles on.
The only way this thing is even slightly not crazy to do is where you have the choice made for you by the product that it needs to be refit. So one of the other vessels we're doing is a 47-foot trawler that was built back in the late 70s, 73 or 74, and then went commissioning 75 or 76, and it's had the original generator and engine on board since then, and they've used the boat a lot, so it's time, right? So, and when you compare the cost of a refit today versus a repower with ICE engines and generators, it's pretty much the same. And so that's, for me, was always the logjam, is I don't like doing something that costs people a lot of money, unless it's money that needed to be spent on the application anyways. If this is a 5-year-old boat, and this guy's kind of fall into this category a little bit, in that they had just finished a refit of it, but Blaine's goal in life was to be a serial hybrid, so whatever it made sense for him.
Serial hybrid, it almost sounds like a serial killer.
The beauty of this boat is simply that the platform has got the lifespan to carry it out. It will last another 25 or 30 years as a boat if it's well taken care of. It's a really robust built vessel anyways. And when we look at all these vessels, like casual, absolutely, I wouldn't sell you a system if it didn't make financial sense. And then once you've got the initial cost at sort of a comparable level, and you guys will get to follow along with all of that as well. What you'll start to see when these guys go into the water and start powering along with this thing is that you'll be able to data log what their old performance costs were versus their new performance costs. And for those of you who are legitimately skeptical, and I completely understand where you come from, my cup is half empty until I've eliminated all the risk, and then I become very half full. But in this case, you've got a nice working, living, breathing platform that you'll be able to compare data maintenance, you'll be able to compare fuel consumption, you'll be able to compare performance, and then the subjective benefits of sound and quality of life on board and things like that. And you're doing it in a way that you're just not going to get the opportunity without having to spend a whole lot of money to do it for your own boat. And when your boat gets to that stage and it needs to be refitted one way or the other, the technology is just going to keep getting cheaper and better and broader in terms of supply. We will go to solid state batteries eventually. We will go to DC generators eventually. We may go to completely alternative sources of energy storage and hydrogen generators, let alone diesel generators.
Think Mr. Fusion.
But you've got to let that, in the marine industry, we are not early adopters, right? We adopt validated, proven stuff, and it has to do that, or it's not worth putting in the boat.
And I think we want to show it on YouTube, and this is why we're doing it, because there was the issues with the winds and the HH catamaran. Like, there have been issues with hybrid electric out there. We want to prove that it can be, first of all, done on a powerboat. And we're taking a commercial system that has been proven on many ships going back and forth across the oceans. We're putting it onto a recreational boat, let's say, and proving that it can work.
Rather than buying a lot of products for people that are super excited to get into the electrical market that are not necessarily proven. Because there are a lot of companies out there that just want to get into this market space and they don't have the background with electrical propulsion.
No.
And we're seeing a lot of those failures now, which is unfortunately where a lot of this stuff is tarnishing the reputation of hybrid vessels.
You have to build it and break it until insurers regulate it, basically.
Yep.
And until then, you're going to find that you get there's a huge market of DIY. And I've met some incredibly good, passionate, crazy people doing it yourself stuff. And they're willing to take the risk, and more power to them. The successes and the failures that they bring to the table are all learning curves for all of the people who can put the money into building commercial systems that are going to be able to supply. And it will take another 7 to 10 years, guys, before what we're doing here is the norm rather than the exception. Right now, very much this boat is the exception. It's not an exception, it's the exception.
Now, how do I say that? Mikado says this system will not even reach 20% efficiency compared to the two old diesels at 40% efficiency.
I'm not quite sure why you would say that, but
I don't know.
I'm more than happy.
How efficient is this going to be? What are we expecting?
You're going to be running at cruising speed on a generator. You're going to be sitting at about 85% efficiency.
Yeah.
Overall.
So I'm going down to questions, guys. There's some neat. We're just going to let the discussion go. We don't totally want to chime in now.
I think we're talking about.
Oh, how long are we going to be able to run? So they say, but how long? 30 to 40 minutes? Because today's battery technology is only capable of that. So he says that the technology is only going to allow Tangaroa to run for 30 to 40 minutes at our regular 8.5, 9 knots. How long are we actually going to run for?
No. Well, in the case of this, let's just pretend we end up with 350 kilowatt hours of energy storage. So of that 350, you're going to discount about 20% of it. Okay, so take 70 kilowatt hours out of that, and you get to 280 kilowatts. Okay, and then if you take the 45 kilowatts, or just say 50 for argument's sake, and divide it by that 280, that's what the usable energy and propulsion time is at that speed. So you've got about 5-ish hours that you could run fully electric before I would say you would need to charge the batteries.
Now, I'll add to that. The biggest issue that so many people make, and they made this when I went from the Detroits to the Cummins, is way overestimating how much power it takes to push this boat through the water.
Yeah.
I can confirm with you, by even my calculations on fuel burn on the Cummins engines, that we were at the most 80 to 90 horsepower is what it took to push this way. And that's horsepower, not kilowatts. Horsepower, 80 to 90. And that's not taking into account efficiency losses on the engines when we're only running at 1500 RPM and 20% load. Like, it doesn't take a lot of power to push this boat. I think he says, yeah, right there, Mikado, scroll down, right there. That is 100%. I can confirm that is twice what it takes to push this boat through the water.
So we only take, 80 to 90
and that's
kilowatts?
That is 100% based on fuel burn. That is irrefutable.
Yeah. And guys, all I can tell you is that regardless of source of energy, power is power, right? And the single most important piece of equipment on a boat is the propeller, in terms of shape and efficiency, in terms of matching the performance of the hull. But whether power is from fuel, wind, sun, solar, hydrogen, strong fart, I don't care. As long as it represents the energy required for the propeller to turn, it will do so. Now, durability, and that's why you have the generators, is you may not want to run fully electric other than going in and out of harbor sometimes and freaking people out at the fuel docks. But you have that 40-ish mile range at your cruising speed with this boat with something like that as a battery bank. I will tell you comfortably, you count the number of times with two hands that you don't ever need to, that you will run electric, right, all the time. Mostly you're going to go electric when you're trying to be sensitive to the environment that you're in. If you're just doing a short hop of 20 miles, you might just say, I just feel like being quiet today and not running a generator.
We run electric when I say, I'm done, turn off the engines, let's have some peace and quiet.
Yeah, but other than that, you're just looking for the most efficient transportation power, which is you, and you don't want to show up. I am a big believer in running electric all the time, but I hate showing up at an anchorage with an empty battery and having to charge my boat then. I'd much rather show up with a full battery and then just have everything off for 3 or 4 or 5 days.
Blaine's the same way. He hates running generators and anchorages. Hates it.
Mm-hmm.
Yeah.
Well, it didn't help that ours was really loud.
Sure.
Well, it's again, that's personal preference, right?
Sandro says, ideally, you'd want the system to allow for the stabilizers and maybe possibly a valve thruster, or the conversion to hydraulic power would be efficient enough. Stabilizers never stop. Big power hogs.
They are big power hogs, and there are stabilizers on this boat. We just don't, in the single line diagram, they're just not relevant. That comes into play in terms of a consumer at another level when you start talking about major draw. But on a boat like this, your refrigerator, your stabilizers, those are the two big beasts in terms of power consumption.
And for us, computer, actually.
Yeah.
Gaming computer.
Yes, we have gaming computers.
Yeah.
You're 100% right. And when we get to doing the breakdown of the performance curve and the demand curve, which we'll do another show, then you guys can see how we calculate the loads, the frequency of use, the average consumptions, and all of that factors into, are you running 1 or 2 generators, right? So at the end of the day, the operating profile has to match the expectation of the vessel, nothing else. And that's the way it will be set up to operate.
So I don't know if Tim is right. He thinks the batteries will push the boat, push Tangaroa a longer distance compared to the time it takes to charge the batteries. So he thinks we can go for 6 hours, but it'll only take 2 hours to charge it.
That's true.
That's amazing.
Yeah.
Mm-hmm. So yes, you're right, Tim.
It all depends on how many generators we want to start up to charge.
Yeah.
Yep.
But that's true. Your charging can be real quick. It just depends when you get there. Like we typically show up at anchorages at around 3 or 4 in the afternoon, and we don't want to be those guys during a cocktail party firing up generators. So we always try and show up full so that we can wait until the day after, the day after, the day after. But really pick it when most of the boats go on shore for lunch or something like that, and then we do fully charge. And my boat takes about 2.5 hours to charge, but I don't disrupt anybody's life. And mine is a doubly separated exhaust system to try and keep it super quiet, anyways. And I expect we'll end up with separated exhausts on this vessel as well. Just so that you are as least impactful when you're operating as possible.
Jeremy wants to know, on these type of electric setup, have you ever tried the Sharo props, as they claim to be 10% more efficient than standard props?
You know, I have never, and I have always wanted to find somebody who was willing to try one of those props.
I spend the money for one of those props.
Yeah.
They're expensive, aren't they?
I have no idea what they cost.
I
like
think
the
for
design
small
concept of
boats,
them.
I think for small boats they're like 5 times the cost or 4 times the cost of like for outboard motors.
If anybody's got a contact.
I love the principle of those propellers in terms of efficiency, and they would be fun to give a spin to, especially on something with full power on at 1 RPM.
I see the spin too.
Spin to, yeah. You caught that.
Yes. Yes, we will be doing cardboard, but door skin mock-ups. We aren't as advanced as UMA. I don't know if anybody watches Sailing UMA when they did the 3D design, but they're architects. We're not, and we're kind of an old school. So we are going to get our glue gun and our door skin up with Brent, and we're going to glue the sizes together, and we're going to place them where we think they're going to go.
Generators.
I think they're going to be good forts. It's going to be fun. We need a floor first, though.
Mock-ups, yep.
I think fully charged batteries will push the boat further than if you're using just the diesel engines to push the ball out.
Makes no difference.
Power is power. So Brent from Fabrizio says, what do you think of having the ability to isolate batteries and runoff generators only, let's say for various reasons?
Isolate batteries and runoff generators only. You mean like a parallel system?
Yeah.
Yeah. Totally okay with parallel if it's the right thing to do. Every vessel, every owner is a little bit different in their expectations, and the duty cycle of the vessel, whether it's an icebreaker or a harbor tug or a pleasure vessel, there is always a few ways to split the atom and figure out how you want it to work. So if Blaine had come to me and said, I want to have a parallel system instead of a series system, I would have said, okay, we'll design a parallel system.
William wants us to take a look at Project Yacht on YouTube, the system behind our new solar electric on YouTube. I think this episode will give you a lot to consider when choosing the boat system. And watch that one, Project Yacht. Remember that. Okay.
Should be easy to remember.
So I'm going to pop through comments, guys, because we're running for 25 more minutes. So we're all leaning forward because we are seriously all Gen Xers and we've lost our eyesight. If the efficiency is a little short of what you expected and it's the propellers, that will help. Is this company going to buy you new propellers? Are you buying us new props?
Well, they're not buying us anything, but
no, we're paying for it ourselves.
we may look into different props.
Yes.
And again, I think if the boat is not close to turning its numbers, and we can isolate that problem down to the propellers, then you've got to look at the wheels, right? That's just the way that's going to get to. But very much like what we did in Australia, we literally said, let's just give it a spin and see, right? Because there was a lot of, if you want to talk about commercial skepticism, oh my God. There were people who didn't want to work on the project because they didn't think it could work at all. And this week we took it out for its final commissioning, and the boat runs beautifully. If it was wheeled properly, we'll know what the top speed of the boat is. I know pretty much what it'll do. But every prop guy we've spoken to on it says, okay, we'll end up with that thing running 13 and a half or 14 knots. That's where it's going to go. At the same time, when I'm sea trialing the boat, she's very nose heavy, and she digs in as she's getting towards the planing point. And so I've asked them, while they take the boat out to get the wheels reworked for the right size, to put lifting strakes on the front of the boat, because I think if we can reduce the energy it takes to keep the nose up just by adding lifting planes, then we can probably pop up a lot faster and use a lot less of the battery to get to that planing speed for that boat. And so every boat has very different performance characteristics just based on its balance, the hull design, the propeller, or even the rudder can impact how well it's going to work. And you just have to look at everything until you get it right.
We've talked about this one already.
Gary wants to know, why can't you just use the generator to directly power the battery chargers so you don't have the phase issues? That way you only have the DC out and AC in directly to independent battery chargers.
Yeah. That is the conclusion we came to, Gary. That's exactly what we're doing.
Fabrizio wants to know about thermal runaway. We're not going to answer it now. We have a
Which is the
thermal
question?
runaway for the battery banks.
Yeah.
We have a whole live coming about thermal runaway and fire safety. Do we not?
And Fabrizio, I can tell you comfortably, I've blown up an awful lot of product in chase of the perfect firefighting system and fire management or temperature management. And the key with the lithium battery in any chemistry and any design and whatever it is how well can it manage temperature through operation. Because if you can keep its thermal runaway threshold temperature away from the temperature of the battery, i.e. never approach that number, it's very difficult for the battery to go into thermal runaway unless it has a cell failure on the inside. But your firefighting and your fire management system has to take into account the inevitability that there will be a cell failure at some time. And then it's how you manage that expectation. And in this case, you're going to have, quite likely it's going to be 4 battery banks, but let's just pretend it's 2. You still have the ability to take one of those battery banks offline while you effect that repair and put it back into service again.
Redundancy.
Yeah, and you may not have the full range of time, but you would have the full power of time. There'd be no problem with one battery bank supplying all the power to both of the e-motors to do the cruising speed of the vessel, certainly, and even a bit more.
But this is, I'm going to interrupt you because this is a hot topic. We can go right down the fire wormhole.
Yep.
or we can leave it for the next live.
No, there'll be a whole discussion about
I know, it's a big one.
firefighting, and it's in this market. It's a really, really hard question to answer because most of the smaller firefighting systems are simply not designed or proven around the commercial use of marine. So they haven't been validated by any of the entities that people look to for that kind of answer to the test. And so we're pushing lithium technology to its limits in smaller vessels, especially as it relates to charging and firefighting management. But when we do the fire system on Tangaroa, I can do a full 2 hours just on what are the risks of fire, how do you mitigate that, and then how do you manage that, and what's the impact, and how do you deal with it if it does happen.
It is all coming, guys. Trust us on this one. Rick wants to know, wondering about the fuel bunker sizing you have. How long will full load last with this system approximately? We have 3,000 gallons on board. How long are we going to last for?
We'll be a little bit shy of that because we're going to shrink down the day tanks a little bit. So I'd say we're probably going to have, there are 2,800 gallons, somewhere around in there.
Still arguing about this, discussing.
Theoretically, with the Cummins, the base mileage would have been around 5,000 nautical miles, but that's like perfect. And that never happens on boats. I'd imagine with this, we're probably going to be...
It's a bit better than that, but not significantly. 6,500, 7,000 nautical miles is what the math says in a perfect world with no tide, current, or wind or waves. But
6,000 to 7,000?
Yeah. I think it's actually closer to 7,500, but let's just say 7,000 for argument's sake. But in my experience, again, if you look at Karma, that vessel went from having a 1,000-mile hypothetical range to having a 1,700 nautical mile hypothetical range. My experience directly with that vessel, at 2,500 nautical miles, I had only burned up 140 gallons, but I sailed 2/3 of the trip. So we found that its relative consumption fed along the lines that my real fuel savings would have been that I would have had about 1,250 to 1,300 nautical miles when I was having to use my engines all the time. So it's about 30% better, 40% better than what I had before.
Awesome.
I was okay with that.
They want to know how to reach Brent directly. You need to go to the OSEA website, osea-boats.com, and enter in their email there. There's an email inquiry on Contact Us. Just go in there, get the email, and then I think the email goes to Sylvie, and she'll reach out, and that's how you get a hold of Brent. Okay, osea-boats.com. You can also, I think there's a link in our YouTube descriptions and on our website. Oh, Eric, I'm really annoyed that Cosworth seems uninterested in responding to my request for info on the 37 kilowatt cat gen.
Don't be surprised. Some of those companies are really hard. I've got emails out to companies too that I haven't heard anything back. So, unless you're a big company and you look like you're a big company, a lot of them no interest in chatting with you.
William says he likes our footage because we're keeping him longer than his 5 minutes attention span.
Wow.
Dwayne is in 50 degrees Fahrenheit in Wisconsin. Is that 20 degrees?
Chilly.
That's chilly. Yeah.
Is it?
Well, no, 50 Fahrenheit's not bad.
I don't know what that is.
50, that's above freezing.
Yeah.
So that's probably around where we are. I think we might be.
I can't believe it's that warm in Wisconsin.
I know.
I know.
Fair enough.
Sorry, guys, we're not going to get in about the whole battle-borne batteries. We just don't know enough about them to comment, and I don't think we wish to.
No. And again, guys, all I can ever tell somebody is be very, very, very aware of what you need a battery to do before you choose it, and don't choose it based on anything other than the performance metrics matching your expectations. You'll be happy. But the one other caution I give people who go down the road of replacing lead acid with lithium batteries for hotel loads is you need to really, really significantly look at the air ventilation and temperature management of the battery space. It is the single largest impact to any product's performance viability. And the lithium batteries, with greater power comes greater responsibility kind of story. If you don't increase the ventilation purposely and make sure that the batteries can manage temperature, if you don't have your cable lengths between your terminals exactly even to your bus bars, if you don't do some very simple fundamental things, it's not the battery that's the problem, it's the installation. And if you want to take the battery out of the problem and it still becomes a problem, then you've chosen the wrong battery, or the battery's promised something it simply can't do. So the world is relatively simple, and be cruel and be hard in terms of your selection process of whatever you put in your boat. Cable length management, absolutely the number one installer mistake is that they think they can use their lead acid cables on their lithium batteries, and you just cannot do it. They won't balance. And they'll get more and more out of balance as time goes on if the cable lengths aren't correct.
So we get email sponsors or email sponsor requests from lithium battery companies, probably 1 to 2 a week right now. Okay. We are choosing to pay for them ourselves and to decide which ones we want, because we're just not going to take a free lithium battery and put it in Tangaroa. Sorry, guys. Yeah, we need to find the
As
proper...
Brent puts it, we have to find the right answer to
Yes.
the test.
So we could get a whole bunch of free lithium batteries, and we've had the offers, but we're choosing not to because we want to be able to choose and find the right one for Tangaroa. Bonita says, just finished watching your last video. It's astounding to watch Blaine remove all the wiring with the confidence in being able to put it back together. I think he's putting that back together?
Of course I am. Who else is going to do it?
Janice is going to do it.
Oh, yeah.
Ben David, have you considered connecting a 50 kilowatt charger to each generator? Would eliminate the need to synchronize the generators and provide a very high level of redundancy.
That is exactly where we're at right now with the AC system.
Dwayne's here from Wisconsin. Again, we said, oh, not sure the OSEA web form is working. Thank you.
Okay.
Do you guys have an OSEA email?
Yep.
info@osea-boats.com. Is that it?
Yep.
Okay. Do you guys
works as of this afternoon?
Info?
I believe so.
Okay, hold on, guys. Let me see if I can.
I haven't emailed that today, but I've been on the website and answered email today.
Sorry, like info at
we are switching web host
dash
stuff right now, but I don't think that's this weekend.
.com. If not, guys, email me, crew@onboardtangaroa.com, and we will forward it to them. Okay, but there you go. info@oseaboats.com. Okay, sorry. Oh, okay, we have 15 minutes. How many do you think we can power through?
Oh, gosh. That got a lot bigger.
I told you. William was out. He was in the Keep the Detroits camp at first. You remember that?
Yeah.
We remember that, William. You were definitely against us taking out the Detroits. Yes, they were loud. Sorry, I'm going to pop right through. The retro shooter. Can you let me know when you want to do a house swap? We're building a Prevost coach right now. Would be a fun exchange. Blaine! Oh!
Don't tempt her.
Let's chat. crew@onboardtangaroa.com. People, yeah, you're right. People told Elon that EVs would fail also. Told him AC motors would not work.
Yep.
Yeah. Following with fascination. Hi. Hello from Darwin, Australia. Hey, little story. I started my sailing around the world in Darwin. I did love it. You guys have jumping alligators or crocodiles. They jump right out of the water. Crazy.
Swimming crocodiles listen in the
sea roos.
Sea roos, I know. Wrightspeed developed a turbine generator for hybrid truck use.
Yep. Those turbines are phenomenal. Like, those turbine generators are so efficient at energy generation. We did a number of trucks for Walmart in the States. Mm-hmm. If you look it up on YouTube, it's called the Super Truck. And those vehicles now have all over 1 million miles. They're working with a gas turbine charger and a 100 kilowatt hour battery bank. And they were as fuel efficient with 70,000 pounds on the back end as a F-150. So they were an amazing performance breakthrough, but we could not get any of the leasing companies to adopt the technology. Walmart did, but we built about 30 vehicles like that for them, and about another 60 for Peterbilt for their just customers in general. You can look them all up. And they worked really, really, really well, and the payback was frankly awesome, but the commercial barriers were too hard to create a market unless you had $100 million to spend.
That's hard. Blaine, can you tell Tony again how it's going to go from forward to reverse will be handled with motors?
It's actually really easy with electric motors. You literally just tell them to turn the other way. They're three-phase motors, and they're controlled by control modules, and they just pulse the phases to control the motor in whichever direction and speed you want.
Lane, what are we going to do about air conditioning?
Open the windows.
We have none.
We do have one air conditioning unit at Ford.
We're in cold
gotta
climes
be
right now.
reconnected.
When we get to the hot climes, we'll have to figure that out.
Yeah, that's not on the radar yet.
Brent, on Karma, are you able to charge the batteries with the propellers when under sail power?
Yeah, but it's not very good. At 8 knots sailing, which is me running along pretty good, the charge rate is about 300 watts. When we did the math on the design of the propeller, we were hoping to get about 500 to 550 watts out of it at that speed. So again, no problem with the E-motor. That's completely the propeller I designed for the boat. And I have to take 100% responsibility. I designed that propeller for going forward efficiently, and that I've exceeded my expectations, but in reverse, it sucks. And for regeneration, we're just not getting the math that we thought we would. So this summer in Mexico, we're going to put our old propeller back on and see what we get with that in terms of real performance. I worked on the design of my prop with two guys who work for a major propeller manufacturer in the States. So we collaborated on the design and structure of it just to give it a spin. No pun intended again. And
you're so punny.
I committed to running it for a year to see how it would perform in all different angles of sail and regeneration, power, and reverse. But I frankly I should have swapped it before we left for Mexico for the old prop.
Mark wants to know if we're going to use or consider generating cooling from the heat.
Oh, for waste cooling from generator.
Waste heat, yeah.
We can. The problem, and especially something like this, is you're so rarely running a generator. Like, for example, when we have to charge our batteries when we're at anchor, it's going to be a 2-hour runtime, and we're going to have days and days worth of sitting around before we have to run the generator again. So the benefits are quite small. I mean, you literally have like a 2-hour window where you can use that waste heat. Underway, sure. I mean, there's probably going to be when we're on a long trip where one generator is running. Yeah, we could use that, but for the typical living stuff, it's not super beneficial.
RV Sparky says we should go visit City Yachts or Yacht City Life with regards to the Prius. I have been in touch with him on Discord.
Oh, have you?
Oh, yeah.
Yeah.
You guys didn't know that. No, I just reached out to him and said, hey.
Oh, cool.
So, yeah, we probably will go visit him. Not tomorrow, because tomorrow we're taking the day off and we're going to Fan Expo, because all the, what are they called?
Lord of the Rings hobbits.
The hobbits are here, and all the Twilight crew is here.
Ron
and
Perlman,
it's crazy.
Bunch of people.
So, Rural Living wants to know why not 4 AC chargers to avoid sync issues.
Same question we've answered a few times.
We talked about that. Sorry, there's some
That's
older
okay.
questions.
Yeah, try to get through the last few of them here.
Oh, this one. It's a good one. RJ Bobley. With the propellers way under the craft, under Tangaroa, they're so forward. Moving closer to the stern and moving the engine room back improves the overall power ratio of the hybrid system. Because our engine room is forward of center and where the props are, if we actually moved everything back, which is crazy, we won't do that, would it actually improve the hybrid system?
It's more about just whatever the balance of the vessel is, and one of the big differences with these systems, so you've got a lot of weight in the batteries, the generators, etc., and the benefit is it's fixed weight, so you want to locate it where it's going to have the best impact to the overall balance of the boat. I don't know how well the hull runs in terms of stern up, stern down, and how it operates at different velocities in terms of its position in the water. But given where everything was in the previous installation with the Detroits, I think we're keeping the balance pretty much on the same line of the boat.
Yeah.
So long as that was okay, then I don't think you're going to see any manifest difference on it. On the vessel in Australia, we took almost 700 pounds out of the stern, and that made the bow even heavier than it was. And it feels like you're driving a car through ice cream right? It's just really heavy on the nose, and the steering is like that as well.
Yeah.
So I don't know. I don't think Tangaroa has that issue.
No. Gary wants to know why not use salvage EV motor and controller so you have a good supply chain. Tesla M3 has a 150 kilowatt motor, 75 kilowatt battery.
You're just all for the wrong.
It's automotive
aspect.
stuff. And comfortably, guys, car power electronics and car batteries are not designed for marine duty cycle or the marine environment. And I can only emphasize that we wouldn't take a project on using a car battery or car structures unless they were designed specifically able to survive in the environment that we have in the marine space. And we are a much more continuous power medium than a car is. Electric cars, and Tesla they've hit it out of the park, as all the companies are doing now. But they design the car around it goes 1 hour in the morning and 1 hour at night, and it has long charging cycles in between. And so that drives a lot of the battery design in terms of heat management. It drives the battery in terms of is it an energy or a power application. And then the motors are just the motors, right? You can put whatever motor on you want. And as long as they're sealed agricultural, then they could work in the marine environment. But the batteries themselves, very much not the right answer to the test to take a car battery and put it in a boat.
Fabrizio, thank you so much for the super
Thanks,
sticker. We
Fabrizio.
really appreciate it, guys. Again, all the money raised is going straight towards its build. It's crowdfunded. So thank you so much. You guys are all part of this, and we really appreciate it. The retro shooter wants to know, have you looked at the CATL sodium battery?
Yep.
I love your answer. Yep.
Yeah. Listen, I apologize. I am not a good person in front of a camera like that.
It was kind of funny, though.
I'm fairly blunt.
I liked it. Yep.
Sodium batteries have just not hit the threshold of commercial viability, and their energy density makes them a challenge to get the volume of energy you want to get in these kind of enclosed applications. We've seen them and have been participant in some fairly large, like 300 megawatt hour systems that have been installed to support foundries and power plants and things like that. And in those applications, they're actually pretty good batteries. They have problems managing thermal runaway. And the reason that they went out of popularity for about 15 years was they had a major fire and discovered they couldn't slow down, like they couldn't manage thermal runaway to a unit. It literally went through an entire 200 megawatt hour system and burnt it all down. The technology that's come into the smaller battery market stuff is better today, but the energy density makes it a hard medium to choose for these applications. It is a real what's the word I'm thinking about it? It's a challenge to balance the risk of the chemistry, whatever it is, against the volume that you actually have. Understand what is the fire management capability of that, and how is the rest of the elements involved able to manage the voltages that work at potentially different levels and different charging scenarios that some of these battery technologies represent. And as much as I'm not the world's greatest fan of iron phosphate batteries, I use them. If I had my personal choice for most applications, I would use an NMC battery. But either one of them is perfectly fine if the battery is designed to make it work. And in marine, we've had a lot of experience of both chemistries where they do represent a pretty good energy density. They give you a reasonable cycle life in terms of quality of performance. They are temper manageable, again, depending on the battery design and the space. But more importantly, the technology has become cost effective, right? When I started producing batteries in 2010, back in 2010, we were $3,500 a kilowatt hour for a battery. Today, a good commercial industrial battery can be had for on-land grid for $120 a kilowatt hour. Marine kind of starts at around 220 or 200 and goes up to about 600, depending on power, energy, what are you using it for. So the price has come down a lot. It's still got more to go. The range of the electronics that can manage the batteries is increasing, but still right now very focused on NMC or iron phosphate as voltages and chemistries to be managed. And I just find that we shouldn't be the first adopters of anything, right? This space is too complex. It's too challenging. It has so many issues with service and support that we should really focus on adopting technologies that have been well established commercially, have a proven track record, have companies that are solid behind them. And then when something has gone out into space and proven that it can work again, and it's twice as much energy density, let it run in something for 5 years, and then it's time to change.
William was commenting about our fuel bill. I think it depends where we fill up, William. Yes, we take 3,000 gallons. I think the last place we filled up was Ketchikan. We usually right now only fill up once a year, because we were down to 5 gallons an hour. We don't fill up very much.
Don't fill up in California. Stop in Oregon.
No, but Ketchikan was really cheap. Yeah, it was really cheap. Okay, we've got 2 more questions here, and then we're going to call it.
I think we only have 2 more questions left.
That's how many we're doing.
Perfect.
Yeah, 2 more. Eric Dunn, a non-propulsion question. Have you considered a sea chest to group all the through-hull connections?
Yes. Right now, we're kind of looking at, with the original Detroits, our main inlets for water are huge. I mean, these things, like massive holes in the bottom of the boat to get water in. I just had them neck down to feed the comments, and I think what we're talking about right now is using those 2, splitting them in T's, and having 4 individual sea strainers for the generators. It won't be everything on the boat. I will still have other things pulling in for water maker and whatever else. But for the engines, we are going to combine them in not necessarily a sea chest, but a common feed off the hull anyway.
Yeah. You know what? We're going to do 2 more because Nathan just hopped online. I want to catch his question. Okay. Nathan, just hold on. You're going to be the last question we do. The first one is going to be the retro shooter. How much weight will it be over the diesel engines?
Depends on which diesel engine.
Detroit's. Let's go Detroit's first, and then Cummins, and then the hybrid.
Yeah. I'm going to assume that we're probably going to come in about 1,000 pounds heavier than the Detroit's.
Yeah. So this is going to be the heaviest. So we went Detroit's
because the battery
Cummins.
went from 200 kilowatt hour to 350 kilowatt hour.
Yeah.
Seems like every time we turned around, it kept creeping up a little bit more and a little bit more.
Brent Fabrizio says you're very good on camera. Straightforward answer. He'd probably answer the same. So good job. And then the last question of the night, because Nathan just hopped on. I haven't seen any comments from him. Hey, Nathan, what diesel generators are you going to use? Size and number. Also, have you determined what voltage you're going to run for the boat as a baseline?
The choice of diesel generators is still not been made. We are down at the brass tacks in terms of choosing. So I think we should probably leave the generators for a separate discussion. Maybe we can combine that with lithium fire safety or something. It won't take too long to do the generator side. But the choice of generator is ultimately, efficiency is one of the interesting things. Blaine and I have both been kind of shocked really at how the difference of a commercial generator for a retail generator is from efficiency. Like, we measure in the commercial world that a good generator from an efficiency point of view is going to burn about 190 grams of fuel per kilowatt hour produced that's a good generator running constant speed, constant power. And a bigger one, like a 400 kilowatt up to a couple of megawatt, we would say that's a happy number to perform at. Where when you ask all those guys to do what they do every day with variable speed, which that's the baseline everyone in the commercial world has, at variable speed, they can go up to 270 or 280 grams per kilowatt hour. So the opportunity to save fuel is big. You can save 80, 90 grams per kilowatt hour, and that's a pretty good rationalization for electrifying a commercial ship. In the retail market, we found that people are promising us the best case performance was like 230.
I think it's like 238 or something like that. But some of them were like 248.
Yeah. So if that's the case, and some of them have offered up something a little better, frankly, you're not looking at massive improvements on the performance on the generators. What you're doing is just using less of them. So your fuel burn is going to be a little less than something that's going to produce 200 horsepower or something like that. And you'll be more efficient. Your emissions are going to be better because one of the things about a constant speed, constant power generator is it reduces your actual environmental impact by about 60% from something that only runs at 50% efficiency. And I'm not talking about true ratings of diesel generators, but if you take a generator and say that 90% is your MCR and that's where you want to run it at best, from that 90% to its 50%, it will comfortably almost double its emissions. And the particulate matter that escapes the exhaust system gains size radically the less efficient the burn. And it's the particulate matter that causes the gases that come off are all terrible. It doesn't matter how efficient it is, you just want less of them. But the particulate matter is what makes the largest impact to the environment, because it introduces something that's very black into an environment like an iceberg or an ice field. And that black absorbs sunlight and generates heat and causes a lot more damage to glaciers and things like that. Like one of the drivers for our commercial marine space has been that we now run cruise ships in and out of the fjords all over the Baltic Sea, Norway, Sweden, Finland, and they have to operate electric for up to 6 hours in order to stop from producing particulate matter from the generators onto the glaciers that they're all spending tens of zillions of dollars to go and see. And it's actually illegal now to bring a cruise ship into that space that can't operate fully electric in that environment, because they were just destroying the thing that they were all going to see. And you're going to find that the particulate matter influence in common ports, Port of LA did a huge study about 10 years ago about the environmental cost impact of all of the diesel generated equipment at the port. And the lifespan of people that lived within 5 miles of the port was 3 years shorter than the average person in the state of California. And it's because they are all inhaling all this particulate matter, and it promotes lung disease and blah, 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 blah. But ultimately, it just costs society a lot more money in terms of healthcare. So one of California, Port of Los Angeles's main drivers is simply to reduce the cost to the healthcare system by cleaning up all of the diesel technology, whether it's a train, a boat, a truck, it doesn't make any difference. They're very committed to measuring the change that they can bring about by improving the efficiency environmentally, whether it's fuel driven or not, of the applications.
And you can probably find all that information at the port website.
Yeah, if you go to Port of Los Angeles and under CARB, that's the California Air and Resource Board, tremendous amount of data there that is this. It's the foundation of so much of the legislation that we're helping to introduce at governments around the world to put a different value other than money on why should you do this? What's the other impact? And if we can extend your grandparents' life by 3 years, some people may not like that. Some people may think it's a great idea.
Anyway, guys.
But actually, on that question, I think as well, currently 4 generators, 50 kilowatts each is kind of the rough idea.
Oh, yeah.
And voltages, generator side, we're looking at 400 volt generators.
Yep.
And on the DC side, we're looking at about 690, 700 volts.
700 volt peak.
And Nathan, we may be related. My sister's actually a Lawless. She was married to a Michael Lawless, who is from East Coast in the Maritimes. So maybe there's some relation in there.
Same Lawless that was on the
Nathan Lawless.
Is the same Lawless that was commenting on our videos that you were talking to, maybe?
I don't know. We could be related. Anyways, guys, thank you so much. It's been awesome questions and everything. Our website has changed a little bit. Go to it. We've got kind of a cool project that might be coming up. And you can get updates about it just by entering your email. And trust me, we're not going to spam the shit out of you. It's not going to happen. But please enter your email for the updates. It's going to be really cool what we've got in the works. We really appreciate each and every one of you. Thank you very much to Fabrizio and Running with Wrenches for the super chats. That, again, much appreciated with his crowdfunding. And if you want to join the crew, head on over to Patreon, which is Onboard Tangaroa 1969, or to our website, and you can join the membership there. And we also have swag.
That's right. I'm not wearing any of this kind of.
He's not. But we do have merch. Thanks, everybody.
See you, everybody.